Hello and welcome everyone. In this video, we will learn about the standard form of LPP, which is the starting point for the simplex method. The simplex method is a fundamental algorithm for solving linear programming problems. We will also learn what slack variables, surplus variables, and unrestricted variables are. In the end, we will see some examples on how we can write an LPP into its standard form. Before moving on to the next slide, please don't forget to subscribe to my channel if you haven't already done so. If you have, thank you for your support. So what is the standard form of an LPP? The standard form of a given LPP should have four characteristics. The first one is that the objective function should be either maximization or minimization problem. That is, we want to maximize or minimize the objective function z, which is a linear combination of the decision variables. Number two is that all the constraints should be the equality type. Number three, the right hand side vector b is non-negative. And finally, number four, all the decision variables should be greater than or equal to 0. Let's look at what slack variable is. It is a non-negative variable which is added to the left-hand side of the constraints with a less than or equal to relation. This is done to convert the inequality constraint into an equality. The key thing to remember is that we add this variable when the inequality constraint is a less than or equal to relation. In this example, S1 is the slack variable and it is non-negative. Surplus variable is also a non-negative variable, but we subtract it from the left-hand side of the constraints with a greater than or equal to relation. In this example, S2 is a surplus variable. One key thing to remember is that both slack and surplus variables are only used to convert inequality constraints into equality relations. They do not play any role in optimizing the objective function. Unrestricted variable is a decision variable that is allowed to take any value that is positive, negative, or 0. To solve any LPP containing unrestricted variable, there is a need to convert the problem such that all decision variables are non-negative. For example, let xj be an unrestricted variable, then we can write xj as a difference of two non-negative variables xj prime and xj double prime. Let's look at some examples. In this example, we have a linear programming problem where we are maximizing z subject to some inequality constraints. We know there are four characteristics a standard form should have, and let's see if the given example has these characteristics. First one is whether the objective function is a maximization or a minimization problem. And we can say that yes, it's a maximization problem. Number two, are all the constraints of equality type? And by looking at the constraints, we can say that this is not the case, as the constraints are of inequality type in this case. Number three, is the vector b non-negative, which it is in this case. And number four, are all decision variables non-negative, which is also true in this case. Now, since the inequalities are less than or equal to relation, we can add slack variable to the left-hand side of the inequality constraints to convert them to equality type. So, we can convert the example into its standard form by adding the non-negative slack variables to the left-hand side of the inequality constraint. Let's look at another example. and see if the given example has these characteristics. First one is whether the objective function is a minimization or maximization problem, and again we can say that yes, it's true, it's a maximization problem. Number two, are all the constraints of equality type? And we can see that this is not the case, as the constraints are of inequality type. Number three, is the vector b non-negative, which it is in this case. And number four, are all decision variables non-negative, which is also not true in this case, as x2 is an unrestricted variable. So in this example, we will use slack, surplus, and unrestricted variables to convert the example into its standard form. For the first constraint, we use the surplus variable s1, and for the second constraint, we use the slack variable s2. Whereas for the decision variable x2, we can write the unrestricted variable as the difference of two non-negative variables x2 prime and x2 double prime. So in the standard form of this example, the objective function becomes z is equal to 6x1 plus x2 prime minus x2 double prime. And similarly, we can update the constraints. Now we can see the standard form has 4 required characteristics. I hope you liked this video. Please don't forget to like and share this. Thanks for watching and see you all in the next video.